Factoring polynomials with a greatest common factor. So first of all, what is factoring? So factoring is finding what to multiply together to get an expression or a number. So basically, we're splitting an expression to the multiplication of simpler terms. Let's go back to an example that makes a lot of sense. So when you had number, let's say 12, and you were asked to find factors of 12, you broke 12 into something like 3 times 4 or 2 times 6. Those are factors of 12. 3 is a factor of 12 because I can evenly divide 12 by 3 and get a result. Same thing with 6. 6 is a factor of 12 because I can divide 12 by 6 and get an even result back. So we are now starting to deal with things that are not quite as simple as 12. We have 4a squared plus 8a. So now we are factoring a polynomial. So this is written in standard form. And when you factor something, we call it factored form. So basically we can see all the smaller pieces that have been multiplied to result in this polynomial here. So you look at each term individually, 4a squared and 8a. First, look at your coefficients. 4 and 8 both can be divided by a 4. So we're going to put that on the outside. I know that this has two a's because a squared is really a times a, and this just has a single a. So at most, I can take one a, I can divide out a single a from the first and the second term. So that means 4a is the GCF, the greatest common factor between these two terms here. Now, that is on the outside of parentheses because parentheses mean multiplication when you have it right next to each other. And what's left over stays on the inside. So if we divide out that common term, that GCF, if I divide by 4a, divide by 4a, let's see what we have left. Well, 4 divided by 4 is 1. And if I have two a's and I divide out one of them, that means you have one a left over. Let's look at the other term. 8 divided by 4 is a positive 2. And then a divide out an a. If I have one a, but I divide out that a, then there are no a's left over. So what factored form is it's made up of, in this case, two items, the GCF here and the remaining leftover pieces. But a plus 2 is also a factor of the original expression. If you were to check your answer, you could simply multiply this back together and make sure you ended up back where you started. So 4a times an a does in fact make 4a squared. 4a times 2 makes 8a. So these two expressions are equivalent. They're just written in two different forms. Now, what happens if there is not a greatest factor between the two or three terms? Well, that means it's something that cannot be factored, and we call it prime. If there is no greatest common number or variable you can divide out, we call it a prime expression. Now, this is not the only method to factoring. There are several methods, but greatest common factor is used everywhere. So here are your general steps on the left. I'm not going to read through them. Let's just look at number 1. So we have 3x plus 12. So if I want to break this down, if I want to find what multiplied to get me 3x plus 12, we're going to first look for a greatest common factor. So 3 and 12. Look at the numbers first. I know that 3 and 12 are both divisible by 3. Now, I see that 3 has an x on it, but 12 does not. So that means I cannot divide out an x from both because there is no x from here to take. So that means my only number that I have is a 3. So my GCF is 3. So what happens is this GCF comes to the outside of parentheses. It doesn't disappear. We have to keep it somewhere. And we see what's left over. So 3x divide out of 3 simply leaves us with x. 12 divide out 3 leaves us with 4. And then we just make sure and see if this can be factored any further. So let's look at x plus 4. So this has a 1 in the front. Well, 1 and 4, the only common number that I can divide out is a 1. So we can kind of ignore that. Here's an x, and this guy doesn't have any x's, so there is no other common factor that we can divide out of here. So our final factored form is 3x plus 4. This is our final factored form. Sometimes all you can divide out is a coefficient or a number. Let's look at example 2. 8m plus 36n. So again, look at the numbers first, 8 and 36. So let's figure out what our GCF is. Well, 8 and 36, I know I can divide both of those by 2. But can you divide by something larger? Because remember, G means greatest. Well, I know that 8 is also divisible by 4, and so is 36. So my greatest common factor is actually a 4. So we're going to divide by 4 and divide by 4. Now let's look at variables. This has an m and this has an n. Those are not the same variable, so I can't divide by any variable. So again, we're left with a GCF of 4. So I want you to pause the video and see if you can write the factored form for number 2. And here's what you should have had for your answer. So the 4, the GCF, comes to the outside, and the leftover after you divide out the GCF is what's inside. And remember, check your answer by multiplying. 4 times 2m makes 8m, and 4 times 9n makes 36n. So these two expressions are equivalent. Let's look at number 3. 14gh minus 18h. So again, start off with your numbers. Let's see if we can find the GCF. So 14 and 18. I can divide 14 by 2 or 7, and I can divide 18 by 2, 3, 6, 9. That's about as far as I can go. So the greatest common factor between 14 and 18 is 2. Now, I also see that this first term has a g, but there's no g in the second term. But I do see that there's an h in both. So I can actually divide out h as well as a 2. So we're going to divide both terms by 2h. So again, just because it's not a single number, nothing changes. Your GCF comes to the outside of a set of parentheses. 14 divided by 2 is 7. And if you do h divide out h, the h's are gone, and all you're left with is g. Negative 18 divided by 2 is negative 9. And if I divide an h by h, there are no h's left. So here is the factored form for number 3. Let's look at example 4 together. We have negative 18a squared b c squared plus 48a b c to the third. So there's a lot going on here. So let's just focus on the numbers. So negative 18 and 48. Probably from first thought, you see a 2. So 18 and 48, I know I can divide by 2. I'm going to show you what happens if you don't take out the highest number possible first. So I know there's a 2. A squared, b, c squared. So let's look at the a's. Here there are 2 a's, and here there's 1. So at most, they share a single a. On the first term, I have a b, and then 1b on the second term, so they both share a b. And then on the third, I have a c squared, and then c to the third. So in this case, they share at most 2 c's, so c squared. So my GCF in this case is actually quite complicated. So let's go ahead and divide both of these terms by 2abc squared. That's the greatest common factor for these two terms. So 2abc squared is on the outside. And now let's see what's left over. Negative 18 divided by 2 is negative 9. A squared, divide out an a, leaves you with 1a. B, divide out b, you don't have any b's left. And then c squared, divide out c squared, there are no c's left. 48 divided by 2 is positive 24. A, divide out an a, we don't have any a's left. B, divide out b, there are no b's left. If I have 3 c's, but I take out 2 of them, then I have a single c left over. Now, before you say you're finished, make sure that you can't divide out anything else. Because if I look at negative 9a and 24c, I see that, well, 9 and 24 still have a common factor. They can still be divided by 3. So what that means is 2 was actually not the greatest common factor between 18 and 48. I could have divided by something higher. So let's divide again. So just on this purple piece, negative 9a and 24c, I know the GCF of those is going to be a 3. Now, we always like this front one to be positive. So normally, we would just divide out a greatest common factor of 3. However, if I want this front number to be positive, I need to divide out negative 3. You can always divide by a negative, but if the front term is positive already, then there's no need to take out a negative. And now let's see what happens. So this is going to stay on the outside. Then we're still going to multiply him also to this new GCF that we have taken out on the step 2. And now let's see what remains. Negative 9a divided by negative 3 is a positive 3a. 24 divide out negative 3 is a negative 8. And then the c will tag along. Now check one more time. 3a and negative 8c there's no common factors here. I can't divide 3 and 8 by the same number. We're almost finished. We just need to clean up this outside piece. So 2abc squared times negative 3. Simply multiply the coefficients together. So my final factored form is negative 6abc squared times 3a minus 8c. So again, if you would like to check your final answer, make sure that when you multiply this in, you get back to the same expression you had in the very beginning. So I'd like you to pause the video and I'd like you to try example 5 on your own. And here's your solution for number 5. Pause the video and try number 6. And here's your answer for number 6. So for number 6, I could not divide out a number because 35, 20, and 6 have no common number divided out through all 3. Yes, 20 and 6 I can divide by 2, but I can't divide 35 by 2. And so there is no common number that I can divide out through all 3 terms. I can, however, divide out an a from everything. When you divide out an a, we still ended up with negative 20 plus 6. Well, those are like terms. So if you try to simplify this as far as possible, you can combine negative 20 and 6 to make negative 14.